So let us continue the electric dipole problems. As we discussed, electric field due to a dipole at its general point will be at any general point will be, as we discussed, at theta angle r distance, answer will be E is equal to kp by r cube under root of 1 plus 3 cos square theta. 1 plus 3 cos square theta. Clear? Understood? So listen carefully now. As I discussed, if it is axial point, you know. If it is equatorial point, you know. Axial point theta is 0. As I discussed in the last class, equatorial point theta is 90 degrees. Yes, you know that. Now, at this point, there are two electric fields. This is E1, this is E2, and resultant will lie like this. And if I say this is alpha, you can see you studied in your board level. So listen carefully. What is tan alpha? Tan alpha is equal to E2 upon E1. What is E2? Remember, as I discussed, this is P sin theta and this is P cos theta. So E2 will be, yes, due to this is equatorial line, Kp sin theta by r cube upon E1 is axial point, 2 Kp cos theta upon r cube. And if you see this clearly, Kp, r cube get cancelled. Finally, this will become tan theta upon 2. So where is the resultant? Yes, tan alpha is equal to tan theta whole upon 2. Mind it. Now if you see, concentrate this. What is this exactly speaking? P. What is this? Theta. And if you see the diagram carefully, if theta plus alpha is 90, what does it mean? If this is P, resultant at this point is exactly perpendicular to P, 90 degrees, which is nothing but theta plus alpha. Clear? Now see, now it is crystal clear. If you go through this, listen carefully. If I substitute alpha as 90 minus theta, then this will become cot theta, because alpha has 90 minus theta. If you see alpha, theta goes that side, 90 minus theta. So cot theta is equal to tan theta by 2, and hence I can say tan square theta is equal to, because this is 1 by tan theta, cot theta can be written as, this tan theta goes that side, is equal to 2, then tan theta is equal to root 2, then theta is equal to tan inverse root 2. So please take care. They will ask you the straightforward question. If dipole moment vector is perpendicular to the net electric field vector, then what is the angle? Answer must be theta is tan inverse root 2. Till now, in NEET exam or in JEE, not at all asked. So please make sure this type of questions they will ask you. Understood? Gotaitama? So, listen carefully once again. They are asking electric field due to dipole. and in the question paper they will give if electric field is perpendicular to dipole moment. Electric field is perpendicular to dipole moment, then theta will be tan inverse root 2. Theta will be what? Tan inverse root 2. Hope so understood. Clear? Yes. So on dipole, what type of questions they will ask you? On dipole, what type of questions they will ask you in NEET level? So listen carefully. There is a dipole which is given as short dipole. Short dipole given in the question, or ideal dipole they will give you. And they said at this point, and at this point they will say that a point charge is kept. Then the question is, find the force acting on the point charge Q kept in the field of short dipole. So that was the question. Kept in the field of short dipole. So if you see it carefully, this is kept in the field, and first of all let me tell you, is this non-uniform field or uniform field? Yes, you can see electric field due to a dipole at its axial point, which is at a distance of r, is electric field is 2 kp by r cube. 2 kp by r cube. So now see, electric field is 2 kp by r cube, and when r changes, when r increases, electric field decreases. So obviously no more question, that is a non-uniform field. Uniform field means what? Everywhere it remains constant. It is position independent. So coming to the line, this is non-uniform. Yes. So let us see. And the shortcut is given as like this. Please try to understand. Shortcut is given like this. Force is equal to P dE by dr. This is method 1. To solve the question, this is method 1. Please try to understand. But I am not interested on this. Straightforward, I am interested on method 2. Method 2 will be, listen carefully, method 2 will be F is equal to straightforward EQ. What is E? Electric field due to dipole. What is Q? The point charge. Done. Electric field due to dipole at that point will be, yes, you got it, 2 kp by r cube into Q. So this is the answer, just a single step for competitive level. Of course, this is quite interesting, which is equal to P into d by dr of electric field due to Q, because for every action there is equal and opposite reaction, whether force acting on the charge Q by the dipole or on the dipole by the charge will be same in magnitude. So let us see dE by dr, that is kq by r square. So due to this point charge, at this point at r distance, electric field will be kq by r square. So I can solve in this way also. So 1 by r square, this is p k q 1 by r square, differentiation will be r power minus 2 means minus 2 r power minus 2 minus 1, then answer will be minus 2 kp q by r cube. Clear? This is force acting on dipole by point charge. Clear? And this is force acting on point charge by dipole. It is crystal clear. If you see these two, both are equal in magnitude, opposite in direction. No more question. Clear all of you? So make sure about this. Clear? That's all. So in this way they will ask you the problems. You can solve either by using method 1 or you can solve by using method 2. That's up to you. Clear? Now, listen carefully. Force between two dipoles. Force between two dipoles. Force between two dipoles. So there are two dipoles. Yes, this is dipole P1. Yes, this is dipole P2. So please make sure these two are separated by r distance with respect to their centers. Now question arises. So this field is non-uniform axial field. So this dipole is kept in the field of first dipole. Once again, dipole 2 is kept in the field of first dipole. Clear? Now listen. Now listen carefully. So when non-uniform field is there, it is so crystal clear. F is equal to P dE by dr. If you write 1, means force acting on 1 kept in the field of 2. So kept in the field of 2. This is how you have to understand the subject. My dear, clear carefully. Clear? Understood? Listen carefully. P1 d by dr of what is electric field due to 2 at this point. Yes, 2 kp 2 by r cube. Sometimes the question may change. Force acting on 2 by 1, that's up to your knowledge. So this will be 2, this will be 1. This will be 2, this will be 1. Is it clear? I can change because I want magnitude. Yes? Now let us see. 2k P1, P2 are constants. 1 by r cube. Differentiation of 1 by r cube. It comes up minus 3. X power n formula. N into x power n minus 1. So minus 3 by r power 4. That's what you know. So here for that minus 3 by r power 4 will come, then answer will be minus 6k p1 p2 by r power 4. So this is F21, and of course F12 will be plus. My intention is to tell you, till now not asked this question, force acting between two dipoles is inversely proportional to fourth power. Is inversely proportional to fourth power. That's all. What does it mean? So listen carefully. If this is dipole P1, this is dipole P2, if these two are separated by distance r, now if the distance got double and if the force initially between them is F, what happens to the force F dash? Yes, it is very clear, inversely proportional to r power 4. That means F dash by F is equal to r2 power 4 by r1 power 4. Wait a second. Clear? No. Is it clear? F dash? No. This is 1, this is 2. Because F is inversely proportional. What is r1 power 4? R. What is r2 power 4? I can write it as 2, 1. Better understanding. Clear? Now r1 power 4, r power 4, r2 power 4, 2r power 4. 2r power 4, r power 4, r power 4 get cancelled. 2 power 4, 2 into 2 into 2 into 2. 4 4s are 16. So hence answer will be F2 by F1 is equal to 1 upon 16. So final answer will be F becomes, F2 will become 16 times reduced. So this is how you can solve the questions. Clear in all over India competitive level. So please try to analyze the question and you can answer it very well. So till now I had been discussed with non-uniform electric field. So let me discuss about dipole placed in uniform electric field. Yes, you studied in board level, I do agree. Heading is dipole in uniform electric field. So dipole is in uniform electric field. Clear? Clear all of you, dipole is in uniform electric field. Okay, done? So this is a uniform electric field. What do you mean by uniform electric field? Lines should be parallel. Lines should be in unique direction. Lines should be straight. And finally, lines should be maintaining equal distance. Yes. Now in this is possible because of sheet of charge. I hope everybody know about this. Sheet of charge. Positive, 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 positive. You know about this. In board level you studied. Sigma by 2 epsilon naught is the electric field which is path independent. Which is path independent. Crystal clear. Now in this, I am placing a dipole like this. Please make sure, try to understand positive value and negative value. Yes, because that is plus q and minus q, and you know electric field, and you know dipole moment. This is dipole moment, this is electric field. What does it mean? Dipole moment is in this direction, electric field is in this direction. P bar E bar. Clear? Now see, miracle is going to happening. This is positive. On this positive, because of this positive, repulsion will act. That repulsion will be like this, which is EQ. And similarly on this, attraction will happen, which is EQ. And you can see clearly, you can see if there is a dipole like this in between my hands, you see the upper hand is moving that side, this side. You see the force that side, and the lower hand pulling this side. So obviously this chalk is rotating. If you see the chalk is rotating, right? So the same way this dipole will rotate. Now the question, in what direction? Question is, in what direction? Direction, clock or anti-clock? Yes, of course, it will be rotating in clockwise. Where it is crystal clear, rotational effect is taking place. Rotation. In what direction? Clock. It was crystal clear, it was clock. Clear? So when it is clock, torque I have to write. You know, that is clockwise. So I had to start from P and I had to turn towards E. No more question. So this will be P bar cross E bar. It was not E bar cross P bar, mind it. It is P bar cross E bar. Clear? Now, what is the net force? Net force is EQ plus E minus Q. Yes, answer is smiley, obviously 0. Net force acting on a dipole. Net force acting on a dipole kept in uniform field is always 0. Please mind it, is always 0. Dipole, whether it is electric dipole, whether it is magnetic dipole. Field, whether it is electric field or magnetic field. So mind it, whatever may be the dipole, whatever may be the field, but remember, relation should be there. Electric dipole, electric field. Magnetic dipole, magnetic field. Always the net force obviously welcomes 0 answer. Mind it. So now net force is 0 and the torque is P bar cross E bar, which depends on sine theta as well. P E sine theta. Now listen, if theta is 0 degrees or 180 degrees, then only torque is 0. Then only torque is 0. Otherwise, torque may be 0, but force is always 0. So, dipole, very very important theory question for all our India exams. Dipole placed in uniform electric field, experiences 0 force always, but the torque may be 0. But the torque may be 0. So please mind it. Clear? Please mind it. Understood? So this is what happening everywhere. Whenever dipole is placed in uniform magnetic field, means magnetic dipole means magnet, or electric dipole placed in electric field, always always the net force is 0, but torque depends on theta, may be 0. Clear all of you? So that's all. Now we will move on to the next. So please all of you always practice, that's all. That gives you a right way always. So please try to understand and please try to practice. Clear? And now potential energy. You studied in the board level. Potential energy of a dipole placed in uniform electric field. Yes, this is a dipole P, and this is theta with the electric field. Potential energy no need to discuss in detail because board level you studied very much. So minus P cos theta. Minus P cos theta, treating the reference as 90 degrees. Okay, done? Now, let me give you the table. With theta and the force and the torque and the potential energy kept in uniform dipole placed in uniform electric field. If theta is 0 degrees, if theta is 90 degrees, if theta is 180 degrees, these are major concern. What is F? Yes, always smiley, 0, because it doesn't matter, net force get cancelled. EQ get cancelled. What about torque? Torque is PE sin theta. है ना बेटा, PE sin theta. Sin 0, 0, तो 0. Sin 90, 1. Sin 180, once again 0. So torque is maximum, that is PE. Coming to potential energy, which is minus PE cos theta. Minus PE cos theta. So now cos 0. Cos 0, yes, 1 minus PE. Cos 90, yes, that is 0. Cos 180, minus 1, minus of minus becomes plus PE. Do you remember in your first year you had been studied about stable equilibrium, unstable equilibrium? They will ask you the questions. This is minimum potential energy. This is maximum potential energy. Hence, this is unstable equilibrium. Unstable equilibrium, very important. And this is minimum potential energy, stable equilibrium. So please try to understand stable equilibrium and unstable equilibrium. Clear? So that's all for the story. So this table is very important. They will ask you the question, dipole is displaced. Dipole is displaced in uniform electric field. In uniform electric field from stable equilibrium, stable to unstable. Stable to, let me write once again, unstable equilibrium position. Unstable equilibrium position. Then find the work done. That is nothing but find potential energy or the work done. You know, potential energy is minus PE cos theta 2 minus cos theta 1. So this is the potential energy, hence it was very clear, minus PE cos theta 2, from where to where? From stable to unstable. Unstable means 180, stable means 0. So this is 180 and this is 0. Cos 180 minus 1 minus cos 0 1. So this will be 2 PE is the potential energy in joules. This is all the story. This type of questions they will ask you, but at the same time they may ask you if you displace, then time period of oscillation will be, if you displace, time period of oscillation will be. So how to do this? It's very easy. Time period of oscillation formula 2 pi under root over I by PE. That's all. Remember, very, very important. Clear? To make it down. So now we will talk about flux. So you studied, I hope so, electric flux. Electric flux is nothing but number of field lines, electric field lines, because I said electric. So number of field lines, electric field lines passing through the given cross-sectional area. In my point of view, intersecting. The number of electric field lines, intersecting the given area of cross section, is called as electric flux. Is called as electric flux. You have to understand what do you mean by intersecting. You see, you feel that my fingers are electric field lines, they are just passing parallel to the surface. They are not intersecting. I am just passing parallel to the board. If I go like this, then that is called as, for this cross sectional area, that is called as intersecting. Even like this, intersecting, not exactly parallel to the surface. The intersecting means, I hope you understood. And mathematically that is represented by phi Greek letter. So this is phi. And now if you see, this is also defined as the scalar product between electric field intensity and area vector, or scalar product gives you scalar only E A cos theta. So please try to understand what is cos theta. Cos theta is the angle between electric field and area vector. So many have confusion. Students have confusion that what do you mean by area vector? Please try to understand. Put your right hand always folding like this. Clear? So you have to put this base point on the surface what you are seeing. So the thumb represents area vector direction. So for the board, thumb is coming out. That means area vector is k cap. Understood? Even for the floor, if you see for the floor, feel that this is the floor, and you have to put your right hand like this, then this is thumb is up. What does it mean? Always area vector is normal to the surface. Suppose if the surface is like this, you can see here, this is x and this is z, then area vector will be top up like this. This is a cap. So in this way, you can put your thumb like this. Yes. If you talk about the ceiling, yeah, you have to put the base, soft one, to that contact. So then thumb is pointing down. If you put to that side wall, yes, this side only should be in contact. Yes, thumb is pointing towards. If you put only right hand, mind it. If you put this side, thumb is pointing this side. Thumb gives you area vector. That's all. So now, so this is all about electric flux. But if you catch up for a sphere, where is the unit vector? So you should go for a patch. Everywhere you should go for a patch. So this patch, normal. So area vector is defined for flat surfaces, not for 3D. If you go for 3D, take a patch, small patch. Like when your cycle tube or when your bike tire got punctured, the puncture wala, the person who fixed the puncture will have a small patch, so that he will detach that and he will attach onto the hole. So that type of small patch you have to understand. Yes? So now this is exactly like this. Clear? So here this patch, the area vector is dA bar, because that is smallest one. Even here the dA vector is dA bar. Is it clear? Clear or not? Yes. So this is how you can analyze. But what type of questions they will ask you? Listen. If electric field is 2I cap, which is uniform field, and passing through the plane, lies in YZ, whose area is lies in YZ, whose area is 20 meters square, then find flux. A very easy and simple question. That's all, nothing else. Then flux will be formula kya? E bar, helama, E bar dot A bar. That's all. What is E bar? 2I cap. What is A cap? Wow. A, you see, this is XZ plane. A is along, yes, Y axis. Similarly, that is YZ plane. That is what plane? YZ. YZ plane means side wall. YZ plane. So thumb is like this I cap, right? So that should be area 20 I cap. Then answer will be 40. And I am leaving units for you because in board level you had been studied. Clear? SI unit. Understood? So such type of questions they will ask you. If I say instead of YZ, if I say the plane is XZ, the plane is XZ, the plane is XZ. XZ means the ceiling, if you see X and Z, and these are passing parallel to that. No intersection flux is because area vector is along J cap. When area vector is along J cap, this is along I cap, dot product I dot J 90 degrees, then flux is 0. Flux is 0. So this is how you can analyze. Understood? So further more questions we will discuss in the next class. Thank you. Till then, happy practice.